Citrus genetic resource preservation, as with preservation of other important crop species, also includes the preservation of related species or taxa, what we sometimes colloquially call citrus relatives. In the case of citrus, using the traditional Swingle taxonomy, we have representatives of 28 of the 32 other genera in the subfamily Orontiordiae, although represented perhaps by only one or two species in a genus which may have over 20 species overall. So one of our longer-term goals is to increase the representation of these wild relatives in the hope that they may have some useful genes. So the related taxa have over the decades proven to be important sources of genes for citrus breeding and selection. Perhaps the most traditional example of this is the use of trifoliate orange in rootstock breeding. So citrus as a perennial clonally propagated crop is generally propagated for commercial use by budding or grafting a scion onto a rootstock. This has been known since ancient times, since biblical times, but became more widespread probably in the 19th century. And so the U.S. industry, which at that time was very small in mostly California and a little bit in Florida, became established by grafting a sweet orange onto a sour orange rootstock. One of the things to take into consideration when propagating these perennial crops is what we call graft compatibility. Some species are compatible or congenial, as they said in the early literature, with other species, and so can make a secure and long-lasting bud unit, whereas other species are not. So sweet oranges, being one of the more important commercial species, was propagated initially by seedlings and later by budding onto sweet orange rootstock. However, this sweet orange rootstock ended up being susceptible to the Phytophthora pathogen, and so large numbers of grafted trees perished, which led to the use of sour orange rootstock, which was resistant to Phytophthora. However, starting about the 1930s, it was found that the sour orange rootstock was susceptible to citrus testacea virus, and particularly to the isolates of citrus testacea virus, which we call quick decline strains, which could result in a quick decline within about 2 weeks of sweet orange graft on a sour orange rootstock. So the search was on for resistant rootstocks to deal with citrus testacea virus severe strains. And it was found that trifoliate orange, Poncirus trifoliata, sometimes referred to as citrus trifoliata after the Mabberley revision, which is tolerant of citrus testacea virus. And it can be used as a testacea-resistant rootstock that is also pretty tolerant, at least some selections, to Phytophthora on its own, or as a parent for a hybrid with other citrus species. And our most widely used citrus rootstocks to this time are generally citranges, which is a hybrid of this tolerant trifoliate orange with a sweet orange, Troyer, and Carrizo citranges, which were developed by the USDA in 1904 by crossing a trifoliate orange with Washington navel sweet orange, produced these two hybrid rootstocks, which account for a pretty large percentage of the rootstocks used in commercial citrus production today. Other more recently developed hybrid trifoliate rootstocks include citrumelos, such as Swingle citrumelo, developed by USDA in Florida in the 1950s through 70s, which is widely used in Florida. So this is an example of related taxa which provided a very important resistance or tolerance gene for a devastating virus disease. More recently, the one-lung bean disease, which is caused by a bacterium, has become detected in a lot of countries in which it was not traditionally established, and these include Brazil and Florida and the United States, where large citrus losses have occurred. So again, the search is on for a resistant or tolerant gene, and some preliminary research has indicated certain of the Oceania-related taxa traditionally grouped into microcitrus and aeromocitrus, but sometimes now referred to as citrus, have these sort of resistance or tolerance genes. It's also possible that other more distantly related taxa have these important resistance and tolerance genes, but they would probably prove to be a little more difficult to hybridize with citrus using traditional breeding methods.